word, and I always forget every single time. Okay, so we're not seeing anything too crazy once again. Can you get crazy? Yeah. Are we going to? No. We'll kind of keep the main concept, but not get too nuts here. So let's see this one. 2 sin theta plus 1 equals 0. Just gotta work my way back and forth just so that people at home can see everything. So if I say 2 sine theta, sorry, I can't remember who it was, plus 1 equals 0. Looks pretty similar. The difference is this one does have a coefficient in front of that sign, which is fine. We can take care of that. Our main goal, I like to remind myself what I'm doing is I want to get this by itself. So to do that, just like if it was an x, same idea. I always add or subtract first. So in this case, I am going to subtract 1. So that's now negative 1. And since I still want this by itself, I don't want that 2 there. It says 2 times sign. I'm going to divide by 2. So those are connected with multiplication. The opposite of multiplication is division. And now we just have a nice little fraction over here, which is perfectly fine because we can look that up in our chart. So I look and I say, what the heck do I get? I'm looking in the sign column where it's equal to negative 1/2. And I'm giving the degree where that happens. So where is that? Oh, that's at 210. Does it happen more than once? It does. It also happens at 330. There you go. So that one we've been adding and subtracting. That one did have a number in front of the trig function, so you're just going to divide in that case. You got a fraction, but not a big deal. You can kind of do your thing from there. Perfect. All right, we're going to do one more of these. You guys are going to try one, and then we're just going to see what happens if it says radians. Basically, you do the same stuff. You're just looking at a different column. All right, let's try one more, kind of similar to that. Let's do 2 cosine theta equals root 2. I feel like all the ones have it equal to 0, but it doesn't necessarily have to be that way. So this one's equal to root 2, not a big deal. So our main goal is to get this cosine by itself, so then I can use my chart. In order to do that, I just see how it's connected to things. Well, it's connected just to that 2 with multiplication. So I'm going to divide by 2. If it's not nice over here, like we can't combine those, that's fine. Just leave it like that. And then we'll see, can we look that up in our chart? So you should always have a value like that. I'm not going to try to trick you. So just make sure you're in the correct column. I'm in the cosine column. I'm following it down and just finding where does it equal root 2 over 2. And then once I find it, I just put that degree. So this one would be 45 degrees. Let's see if it happens more than once. Most of the time it will. And it happens at 315 degrees. Beautiful. So that's kind of the main idea. So can you guys try this one? And then I'm going to switch it to radians and we'll just see how basically it's the same thing. You're just looking at a different column. So you guys try this one. Try this. If I said, hey, can you solve? You can't really get too crazy with these boys. Actually, let's use a different one. Let's say tangent of theta plus 4 equals 3. So it's not always zeros there. Sometimes you have different things. So if I said, hey, can you solve that? Okay, can you get this tangent theta isolated? And then once it's isolated, can you use your chart to look up your theta? So I'll give you a second, and can your answer be in degrees? Just making sure a few people weren't here at the beginning. I want to make sure my attendance is correct. Give you more, 30 more seconds. That one shouldn't have been too bad. Now we're just gonna look at if it says radians, what's the difference? We're gonna see it basically doesn't really make it that much different. You just look at a different column, but I just wanted to show it to you. And we'll just look at the basics and then we'll kind of build on it tomorrow and try a few more. All right, so my main goal is to isolate this. So that's always your, if it says solve, you want to get the trig function by itself. I'm going to subtract 4, okay? Tangent theta is going to equal -1. So I grab my chart because once again, I have no clue what these are off the top of my head. I'm always just going back to my chart. All the work's done for me. I'm going down the tangent column. I'm finding -1. That happens at 135 degrees. It doesn't happen anywhere else. It does. It also happens at 315. So can you please make sure that you got those as an answer? Right now, does anyone have any questions on that one? Or in general? We're keeping it hopefully not too bad with the solving. You can get more complicated, but I'm not going to. Okay. So now the other thing I wanted to show you was just what happens if it says radians, because it does change it a little bit. We'll try a few more. You guys are going to try a few as a wrap up. For the people at home, you'll be kind of, I have to put something up, but you'll be submitting your notes. For the people here, I'll check them quick. And if you haven't noticed, if you basically come to school and like done anything, you probably have a pretty good grade for term 3, so just keep that up. If you weren't here that Friday before vacation, just let me know. We did a little mini assessments then, but I'll have to catch up with people on that. Okay, so the last thing we're doing is basically the same thing. We're solving for theta, except I'm going to change the directions to say answer in, and I'm going to make it radians this time. So it's all just about reading the directions. And I'll give you an equation. Let's say, I'm restarting at 1 here. I don't even remember what number I left off on. Sorry, I'm trying not to make them too torturous. Oh, we can do one like that tomorrow. Let's do, that one's boring. I'm so sick of sine. I don't want to, I guess I will do sine. So 2 sine theta plus 3 equals 4. So we can have numbers wherever. Our main goal, it's the same thing. We're not changing, even though I said radians, we don't change our steps. So our main goal is to find sine theta. So then we can look it up in the chart. So I need to just rearrange some numbers. I always subtract first, or add or subtract first. 1, right? 4 minus 3. Once again, I still want the sine theta by itself, and since it's connected with multiplication, I'm going to divide by 2. Just like solving for x, or for anything. So the only difference now is, I go to my sine column and I look up a half. I can do that. That's what we've been doing. The only difference is when I give my final answer, instead of going to the degree column, I go to the radian column. So it doesn't actually make the problem any different, which is nice. So I would go down sine theta it equals 1/2 at, so I wouldn't put 30 degrees, I would put pi over 6. And it also equals 1/2 at, once again, I wouldn't put 150 degrees, I'm gonna write the radian of 5 pi over 6. So just depending on what we're doing, sometimes we might switch between degrees and radians. So the nice thing is it doesn't really make it more work. You're just looking at a different column, which is delightful. All right, let's try 2 more and then I'm gonna have you guys try some wrap-up problems. What though? Sorry, I'm trying to make these as not terrible as possible. Let's do cos 3 cosecant theta equals 2 root 3. Yeah, that one shouldn't be bad. So once again, don't get freaked out with the radicals. You're just kind of moving stuff around. I'll try not to make it too bad on you here. Our main goal is to get cosecant isolated, aka by itself. I don't want any other numbers on that side. Since there's a 3 in front that's being multiplied, I'm going to divide by 3. Divide by 3. So once again, don't have a heart attack over here. You just basically leave it like that. So I'm going to leave it as 2 root 3 over 3. Because if I look at the cosecant column, that value happens a few different places. Yep. So I'm going to follow it down. I'm going to write my answer in radians, which just means I'm looking at a different column. So when I go down the cosecant column, 2 root 3 over 3 happens at pi over 3. So that's 60 degrees, but I want the radian. And it also happens at 2 pi over 3, which is 120 degrees. And that would be your final answer. So I just wanted to remind you, when the radicals are there, you can just kind of work around them. You just kind of keep them how they are. Don't overthink it. Okay, let me do one more with you. There's a specific one I wanted to do. When something divides out. Let's do 5 cotangent theta equals 5 root 3. So when I look at this, I say, all right, well, I'm doing the same thing. I like to kind of circle or box in what I'm looking for, which is cotangent. I just see how the number is connected to it. That's connected with multiplication, and the opposite of multiplication is division. And we see a lot of the same steps kind of happening here. So when you do this one, I just wanted to remind you, when you are dividing, like over here, I can't really do anything, but here I can, because 5 over 5 is just 1, right? So I would just write this, I kind of just cancel that out, you don't even need to write the 1. I would just write that as root 3. But just as a reminder, when you are dividing, if you can't do anything, you just kind of leave it. But if you can reduce it, please do so. Because 5 root 3 over 5 will not be in your chart, but just root 3 will, since that kind of cancels out to just be 1. So just as a reminder there, I'll go down my chart ski. I want my answer in radians, cotangent. So that happens at 30 degrees, but I'm writing the radian, which is pi over 6. And then what else do I need? Root 3, root 3, root 3, root 3, root 3, root 3. Where is the other? Oh, there it is. So I find it, and it's at 7 pi over 6. So remember, always kind of keep looking. A lot of times there will be 2 answers. So please don't just give me 1, because that would just be the credits. Okay. I'll give everyone a second to get caught up. I'm going to give you 2 wrap-up problems, and that always takes me like 10 minutes to actually check everyone off. And then we'll have a few minutes at the end to check. Yes, sir. When Christine is back. So I'm just going to give you a second to catch up at home. Sorry, checking this here. There's our All right, so here's what you're gonna do. We're going to solve for theta. So number one, I know I keep rewriting number one, but you know, you got the deal. Number one, I want the answer in degrees. Number two, I want the answer in radians. So just make sure you know what you're looking for and you're doing it correctly. Okay. I need my chart so I can give you a nice little problem here. So for the first one, hopefully these shouldn't be too terrible here. I feel like we haven't done any secant today. Let's do a secant. Let's do 6 secant theta plus 5 equals, sorry, I'm trying to make this a nice number for us. 17. Okay, that should work. And then, so once again, the numbers can be a little bit different. That's okay. Your main goal is to get that secant by itself and kind of see what it equals. And that one should be in degrees. And then 2, let's do 3 tangent theta equals negative √3. Okay. And that one's in radians. So give me a second because I need to set the people up at home so you can submit yours. Not yet. Google Classroom. This is 1, you guys are B. Oh, I really wish you just. So at home, as you're doing those and finishing them, can you please upload them into your Google Classrooms, or is it just get all of your notes, please? Not just those 2 last problems, but any notes you have from today, plus those 2 last problems. And I'll give you a heads up when you can sign up. Please do not sign up before then. So it just takes me a second to set this up. Give everyone a few minutes.